Okay, so I've been wanting to make this video for a long time because every time someone talks about ocean predators, the conversation always goes to the same place. Sharks. More sharks. Maybe a giant octopus if we're lucky. But the ocean is so much weirder than that, so much more clever than that. The ocean is full of killers that don't even look like killers. Fish that hunt with poison instead of teeth. Animals that wait, motionless, for days. Predators that can change their entire body in less than a second. Hunters that work together in coordinated teams, like organized crime families. The more I researched this stuff, the more I realized the ocean doesn't have predators. It has a whole underworld with its own rules, its own hierarchies, its own gangs and assassins and bosses. And honestly, once you start seeing it that way, you can't unsee it. So today, on Marine Planet, I want to take you through 8 of the most fascinating predators in the entire ocean. Not the ones everyone talks about, not the obvious ones. The strange ones, the brilliant ones. The ones that have been quietly running their parts of the ocean for millions of years. Some of them you might know by name but never really understood. Some of them you've probably never even heard of. And by the end of this video, I promise you, you're going to look at the ocean differently. Quick thing before we start. If you enjoy these kinds of long-form ocean documentaries, it really helps the channel if you hit the like button and subscribe. I know everyone says that, but on this channel, it's just me putting these together one by one, trying to give you something worth your time. Every subscriber genuinely matters. And while we're going through these animals, I'm curious about something. Which one do you think is the most dangerous? Not the strongest, not the fastest, the most dangerous. Drop your guess in the comments before we start, and we'll see if you change your mind by the end of the video. All right, let's get into it. Welcome to the underworld of the ocean. A foot comes down on what looks like a piece of broken coral. Just rubble, algae, nothing alive. And then the seabed explodes. Before the brain even registers what's happening. Before pain, before fear, before a single thought, it's already too late. Sharp spines have shot upward through soft tissue. Venom is already inside the bloodstream. Cells are dissolving. Pain receptors are being hijacked. This wasn't a chase. There was no warning. No dramatic moment of a predator bursting out of the water. Nothing like that. This was an execution, carried out by an animal that didn't even need to move. Welcome to the world of the stonefish. Possibly the most ruthless killer in the entire ocean. And the strangest part? It does almost nothing at all. Let me show you what I mean. The stonefish is sitting right there in plain sight. It's been there for hours, maybe days, and you would walk right past it. Divers walk past it. Fish swim past it. Even scientists trained to spot it sometimes can't, because it doesn't just hide. It becomes the reef. Look closely. And I mean really closely, at its body. The bumps look exactly like coral polyps. The skin matches the staining of old limestone. There are little flaps of skin that break up its outline, so even the shape of its body disappears. It's not camouflage in the way a chameleon does it. This is something else entirely. This is becoming invisible. Coral reefs are loud places, visually I mean. Colors everywhere, shadows, movement. It's chaos. And in that chaos, the stonefish learned something brilliant. If you can't outrun your prey, become the background itself. Don't look like a rock. Don't look like coral. Look like random debris. Look like nothing. And that's exactly what it does. But here's where things get genuinely scary. Camouflage alone doesn't make a killer. The stonefish has something else. Along its back are 13 sharp spines. They look harmless. They look like little bony spikes. But each one of those spines is connected to a venom gland. And here's the disturbing part. They don't need to be aimed. They just need to be touched. Step on it. Brush against it. Even apply the smallest pressure. The spine pushes down into its sheath, and venom shoots up through it like a tiny syringe. No effort. No targeting. No timing required. It's like stepping on a landmine that grew teeth. The venom itself? It's brutal. A cocktail of proteins that tear through cell membranes, mess with your nervous system, and trigger pain so intense that fully grown adults have described it as the worst sensation of their entire life. People have begged doctors to amputate limbs just to make it stop. And the stonefish? It hasn't moved a muscle. Now, you might be thinking, okay, so it's well defended. But how does it actually eat? This is where it gets even more incredible. The stonefish doesn't bite its prey. It doesn't chase. It doesn't even snap at it. It vacuums it. When a small fish or crab wanders too close, the stonefish opens its mouth in less than a single heartbeat. We're talking about 15 milliseconds. Faster than you can blink. Faster than your brain can even process. And when that mouth opens, it creates a vacuum so powerful that the water and everything in it gets sucked inside before the prey even realizes it's in danger. There's no struggle, no fight, no drama. 1 second the little fish is swimming. The next second it just isn't. And the stonefish? Already back to looking like a rock, like nothing happened, already digesting. People sometimes call the stonefish lazy. They look at it and think, this animal is just sitting there doing nothing. But that's missing the point completely. The stonefish has figured out something most predators never will. Movement costs energy. Chasing costs energy. Hunting costs energy. And in the ocean, energy is everything. So instead of running around burning calories, the stonefish does something smarter. It picks a spot, a really good spot, near a crevice, beside a coral head, along a sandy path where small fish like to feed, and then it just waits. It lets the reef do the work for it. The fish come to it. The crabs walk to it. Prey calculates its own death just by going about its normal day. That's not laziness. That's genius. But here's something most people don't realize about the stonefish. And this part is honestly kind of poetic. This perfect predator, this invisible assassin, is completely dependent on the reef being alive. Think about it. Its camouflage only works because the reef is full of color, texture, and chaos. The moment a coral reef dies, when bleaching turns it white and bare, the stonefish suddenly becomes visible. Its bumps, its outline, everything. The killer needs a crowded room to disappear. Put it in an empty one, and it has nowhere to hide. So, as we destroy the world's coral reefs, we're not just killing the colorful fish and the beautiful corals. We're slowly stripping the camouflage off creatures like the stonefish too. Their entire survival strategy, built over millions of years, falls apart. The most lethal predator in the reef is also one of the most fragile. And one more thing, because I think this gets misunderstood a lot. The stonefish isn't aggressive. It doesn't attack people. It doesn't hunt humans. It doesn't even want you near it. When someone gets stung, it's almost always because they accidentally stepped on one. The venom isn't there to hurt humans. It evolved to stop sharks and big fish from eating the stonefish itself. It's not a villain. It's just an animal that traded speed for armor, movement for invisibility, aggression for patience. It's not trying to win. It already has. You see, the ocean is full of predators that rely on speed. Sharks, tuna, barracuda. They're built like missiles, designed to chase, catch, and kill through pure power. The stonefish does the opposite of all of them. It doesn't move. It doesn't chase. It doesn't fight. It just sits there, quietly, waiting, becoming the floor itself. And every fish, every crab, every creature that swims by it is calculating its odds against an enemy it can't even see. That's the genius of the stonefish. It doesn't hunt. It engineers inevitability. Look at this patch of sand on the reef floor. Just sand. Maybe a little algae. Nothing interesting. Now keep watching. A ripple moves across it. Then another. And suddenly, the sand has eyes. 8 arms. A body that wasn't there a second ago. You weren't looking at sand at all. You were looking at one of the most extraordinary creatures in the ocean. and you didn't even know it was there. Meet the cuttlefish, the greatest illusionist on Earth. Now I want you to really think about what you just saw, because it's almost impossible to wrap your head around. This animal didn't hide behind a rock. It didn't tuck itself into a crevice. It didn't run. It just became the sand. And then it became something else. And then something else again. All in less time than it takes you to blink. How? How does a soft, vulnerable little creature do that? The answer is honestly mind-blowing. And once you understand it, you'll never look at the ocean the same way again. The cuttlefish's skin isn't really skin, not the way ours is. It's a screen, a living, breathing, full-color, high-resolution display. Underneath the surface are millions of tiny color cells called chromatophores. Each one is like a tiny pixel, a sack of pigment surrounded by little muscles. When the muscles pull, the pigment spreads out and the color appears. When they relax, the color disappears. And the cuttlefish controls every single one of them, with its brain, directly. Imagine if you could change the color of your skin just by thinking about it. Imagine if you could turn yourself green, or print stripes across your arm, or make a checkerboard pattern appear across your chest in less than a second. That's what this animal does, all day, every day. But it gets stranger. Below the chromatophores are another layer of cells called iridophores. These don't have pigment at all. Instead, they bend and reflect light, creating shimmering blues, greens, and silvers, like the inside of a seashell. And below those, yet another layer, leucophores. They scatter ambient light, matching the brightness of whatever is around the cuttlefish. 3 different layers, 3 different ways of controlling light, all working together, all controlled by one of the most complex brains in the entire invertebrate world. This isn't camouflage. This is art. But honestly, the colors aren't even the most impressive part. Watch what happens next. The cuttlefish doesn't just change color, it changes shape. Tiny muscles in its skin can push outward, creating little bumps and ridges called papillae. In one moment, the cuttlefish is smooth and streamlined like a fish. In the next moment, bumpy, jagged, rough like coral. Its entire silhouette transforms. Predators rely on edges to see prey, the shape of a body, the outline against the background. The cuttlefish breaks its own outline. It doesn't just blend in, it dissolves. Now let me tell you something that's going to sound impossible. The cuttlefish is colorblind. Read that again. This animal, capable of matching the colors of coral, sand, algae, and rocks with breathtaking accuracy, cannot actually see color. Its eyes don't have the cells needed to detect different hues. So how does it match colors it can't see? Scientists are still trying to figure this out. The leading theory is that it reads the world through brightness and polarized light, patterns we can't even perceive. Somehow, its nervous system translates those signals into perfect color matches for the eyes of other species. Think about what that means. The cuttlefish creates art for an audience it cannot see, in colors it cannot perceive, and gets it right every single time. That's not just survival. That's something close to magic. But here's where the story takes a really fascinating turn. The cuttlefish doesn't only use its powers to hide, it uses them to talk. When two cuttlefish meet, especially during mating season, their skin lights up with patterns. Stripes pulse across their bodies. Spots flash and fade. Waves of color ripple from head to tail. It's a visual language, a conversation written in light. And here's the genius part. A male cuttlefish trying to impress a female might display bold, beautiful patterns on the side of his body facing her, while keeping the other side of his body completely calm and camouflaged. So if there's a bigger, stronger rival male nearby, that rival sees nothing, just sand. The cuttlefish is literally talking to two different audiences at the same time, with one body. It's like sending two completely different text messages from the same phone at the same moment, to two different people. I don't know about you, but the more I learn about this animal, the more I think we've completely underestimated what's swimming around in our oceans. And it gets even more clever than that. Sometimes smaller male cuttlefish, the ones that can't compete with the big dominant males, do something extraordinary. They pretend to be female. They change their colors. They change their body language. They tuck their arms differently. Everything about their appearance shifts to mimic a female. The dominant male sees them and thinks, no threat, just another female passing by. He ignores them. And while the big male is distracted, the disguised male sneaks past him and approaches the real female. He's not just hiding. He's running a con. It's the kind of strategy you'd expect from a chess grandmaster. Not a soft little creature with 8 arms. When the cuttlefish hunts, the deception continues. It doesn't chase its prey. That would be too obvious. Instead, it drifts toward an unsuspecting crab or shrimp while displaying something hypnotic, waves of color that pulse across its body like clouds moving across the sky. Some scientists believe these moving patterns confuse the prey, making it harder for them to focus, harder for them to even notice that something is approaching. And then, when the prey is close enough, 2 long tentacles shoot out from beneath the cuttlefish's body, faster than any reflex, faster than any escape. The hunt is over before the prey even knows it began. And if all of that fails, if a predator gets too close, the cuttlefish has one final trick. Ink. But not just a smokescreen, not just a cloud to hide in. The cuttlefish's ink forms a specific shape, a blob roughly the size and outline of the cuttlefish itself. A decoy, a fake version of itself suspended in the water. The predator strikes at the decoy. The real cuttlefish is already gone. Some species of cuttlefish even mix mucus into their ink, making the decoy hold its shape longer. Others release chemicals that confuse the predator's sense of smell. So even if the predator realizes the decoy isn't real, it can't track the actual scent trail. It's not just a smokescreen. It's an entire fake reality. You know what I find most beautiful about all of this? The cuttlefish doesn't survive by being the strongest. It's not. It doesn't survive by being the fastest. It's not. It doesn't have venom. It doesn't have armor. It doesn't have teeth. What it has is intelligence and imagination. It survives by being smarter than everything else in the room, by understanding how its enemies see the world, and then carefully, deliberately, painting them a picture they can't help but believe. In a way, the cuttlefish is a kind of artist, a storyteller, an illusionist, painting images on its own body for an audience that doesn't even know there's a performance happening. There's a quiet sadness in its story, too. This entire strategy, this beautiful, intricate, evolutionary masterpiece, depends on the reef being healthy, full of color, full of texture, full of complexity for the cuttlefish to mimic. When reefs die, when coral bleaches white and the ocean simplifies, the cuttlefish's library of disguises starts to disappear. There's nothing left to copy, nothing left to become. The greatest illusionist in the ocean needs a stage to perform on, and we're slowly taking that stage away. But for now, somewhere on a reef right at this moment, a cuttlefish is hovering above the sand, watching, reading, translating the world around it into patterns and colors and shapes. To a passing fish, it's invisible. To a curious crab, it's just a piece of seafloor. To another cuttlefish, it's broadcasting 1,000 silent messages. To a predator, it's a ghost. There one moment, gone the next. It is everything and nothing, all at once, all in the same body. The master forger. A small, soft creature that survived for millions of years not by fighting reality, but by learning how to rewrite it. The water is calm, too calm. A school of sardines drifts through the blue, twisting and flashing in perfect formation. Thousands of tiny silver bodies moving as one. Hypnotic, beautiful. And 10 meters away, barely visible against the open ocean, something is watching them. It hasn't moved in 30 seconds. Not a fin, not a twitch, just hanging in the water like it's part of the scenery. Then, it explodes. In less than a single second, the calm shatters. A streak of silver tears through the school. Sardines burst in every direction. Bits of flesh drift through the water. The school splits in panic. And just as fast as it started, it's over. The hunter is back in position, suspended, calm, like nothing happened. That's the Barracuda, the fastest knife in the ocean. I want you to forget everything you think you know about ocean predators for a second, because most of them follow a pattern. Sharks circle, tuna chase, dolphins coordinate. The Barracuda, it doesn't do any of that. It does something far simpler, and honestly, far more terrifying. It just waits, and then it strikes. Once. Hard. Done. This is hit-and-run hunting taken to its absolute limit. There's no chase. There's no tracking. There's no second attempt. Either the strike works or the hunt is over. Most predators give themselves multiple chances. The Barracuda gambles everything on a single moment. And almost always, it wins. So how does it do this? Look at its body. Really look at it. It's a torpedo. Long, narrow, built like a spear with fins. Every line of its body is designed for one thing: explosive forward acceleration. Inside, its muscles aren't built for endurance like a tuna's. They're built for power. Fast twitch fibers, packed densely along its spine, that can release massive amounts of energy in a single contraction. Its tail, forked, sharp, stiff. A blade that converts every flick into instant speed. When a Barracuda strikes, it doesn't accelerate gradually like a car. It launches like a bullet, from 0 to top speed in less than a heartbeat. We're talking about acceleration so fast that scientists struggle to measure it accurately. By the time you see the strike start, it's already over. Now let's talk about something genuinely disturbing. A Barracuda's strike is faster than its prey can react. That's not poetic language. That's biology. When a fish senses danger, electrical signals have to travel from its eyes to its brain to its muscles. This takes time. Real time. Measurable time. Milliseconds. The Barracuda's strike is faster than that. It physically outruns the prey's nervous system. By the time the sardine's brain registers danger, its body has already been cut in half. Think about what that means. The prey doesn't even get the chance to be afraid. There's no struggle, no flight response, no final moment of awareness. It's just gone. Now here's where the Barracuda's design gets even more brutal. Its mouth is not built for catching prey. It's built for cutting it. Most fish swallow their prey whole. They use suction. They stretch their jaws. They engulf. The Barracuda doesn't do any of that. Its jaw is a guillotine. Long, narrow, lined with rows of needle-sharp teeth that interlock like scissors. There's barely any wasted space. Every tooth has a job. Every angle is engineered for one thing: slicing through flesh as fast as physically possible. When the Barracuda hits a sardine at full speed, the prey isn't grabbed. It isn't crushed. It's sheared in half. One pass. One cut. 2 pieces. This is why Barracuda often leave behind drifting fragments. Half a fish here, a tail there. The strike is so fast and so violent that the prey is destroyed before the Barracuda even processes it. Then the scavengers come, small fish, crabs, anything nearby, and clean up what's left. The Barracuda doesn't care. It already got what it needed. Now let's talk about something amazing about how it sees the world. A Barracuda's eyes are huge, forward-facing, almost predatory in the way you'd describe a hawk or an owl. Most fish have eyes on the sides of their heads, for spotting predators in all directions. The Barracuda doesn't need that. It's not worried about being attacked. It's worried about aiming. Forward eyes give it binocular vision, the ability to judge distance with extreme precision. Just like us, just like an eagle, because if you only get one chance to strike, you'd better know exactly how far away your target is. And here's the part that's almost unfair. The Barracuda's retina is packed with cells that detect motion and contrast, especially the flash of fish scales catching the light. A schooling fish reflects sunlight. That's actually their defense. A wall of confusing flickers meant to disorient predators. But the Barracuda's eyes are tuned exactly to that signal. What confuses other predators lights up the Barracuda's brain like a target. Their defense becomes its targeting system. Okay, but here's the question I always wondered about. If Barracuda can only strike once, how do they ever miss? The answer is, they barely do, because they don't strike when they want to. They strike when the math says they will succeed. Watch a Barracuda hover near a school of fish. It's not waiting randomly. It's calculating. Watching the rhythm of the school. Waiting for one fish to drift slightly out of formation. Waiting for the angle to be perfect. Waiting for the sun to be in the right position. And the moment all the variables line up, it goes. If even one factor isn't right, it waits. Doesn't even attempt the strike. Most animals hunt with effort. The Barracuda hunts with mathematics. Now there's something I have to clear up, because it's something a lot of people get completely wrong. You've probably heard that Barracuda attack swimmers, that they're aggressive, that they go after divers wearing jewelry. Let me explain what's actually happening. Barracuda are not aggressive toward humans. They don't see us as prey. We're way too big. But their entire visual system is wired to detect flashes of silver, because for millions of years, that has meant one thing. A fish is nearby. When a diver wears a shiny watch, or a metallic dive computer, or jewelry that catches the light, the Barracuda's brain doesn't see a human, it sees a flash. A fish-like flash. And before its higher reasoning can catch up, instinct fires. The strikes on humans aren't attacks. They're misidentifications. It's a hardwired reflex. The Barracuda isn't trying to hurt anyone. It's just doing what 50 million years of evolution programmed it to do. The lesson? If you swim in Barracuda waters, leave the shiny stuff at home. There's something else worth knowing about this animal. For all its violence, the Barracuda is not the top of the food chain. Bigger sharks hunt them. Larger predatory fish eat juveniles. Even adult Barracuda have to constantly watch for threats from above and below. So this absolute killer, this perfect torpedo of teeth and speed, also lives in fear. It hides in plain sight. It strikes only when conditions are perfect. It doesn't pick fights it can't win. In the ocean, even the deadliest hunters are also being hunted. There's a strange beauty to the Barracuda's strategy when you think about it. In a world of constant motion, currents, tides, schools, drift, chaos, the Barracuda chooses stillness. While everything around it moves, it does the opposite. It stops. It holds. It waits. And in that stillness, it becomes invisible. Not because it changes color like a cuttlefish, not because it hides like a stonefish, but because moving is what predators are supposed to do. A motionless predator doesn't compute. The school of fish literally cannot recognize it as a threat. So the Barracuda turns the rules of the ocean against the ocean itself. It survives by becoming the one thing nothing else expects. A statue, until it's a missile. As I'm telling you this, somewhere out there in the open ocean, a Barracuda is hovering. Right now, suspended in the blue, watching. It's not chasing anything. It's not searching. It's not hunting in the way we think of hunting. It's just waiting. Waiting for the right flash of silver, the right angle, the right distance, the right moment. And when that moment comes, the water will fracture. A streak of silver will move faster than thought itself. And one small fish, somewhere out there, will simply cease to exist. No warning, no struggle, no second chance. That's the drive-by killer. The ocean's reminder that sometimes the most devastating attacks come from absolute calm. Picture a fish that doesn't hide, doesn't run, doesn't use camouflage, doesn't even bother to be sneaky about anything. Instead, it walks into a neighborhood, fins spread wide like a peacock covered in venomous spines, and basically tells the entire reef, "This is my block now, you got a problem with that?" And nobody, and I mean nobody, wants to test it. This is the lionfish. And honestly, it's the most fearless animal in the entire ocean. Let's start with what makes it so unusual. Most predators we've talked about so far rely on stealth. The stonefish hides. The cuttlefish disguises itself. The barracuda blends into open water. The lionfish does the exact opposite. Look at this thing. Bold black and white stripes. Long flowing fins like decorative robes. Spines sticking out in every direction like a porcupine that joined a circus. It practically glows on the reef. You can spot a lionfish from 20 meters away. And that's exactly the point. In nature, there's a strategy called aposematism, and it's actually one of the most fascinating ideas in biology. The basic concept is this: if you're dangerous, advertise it. Don't hide. Don't blend in. Make yourself impossible to miss, because the more obvious you are, the more predators learn to leave you alone. Think about a wasp. Bright yellow. Obvious as can be. You see one and your brain immediately says, "Don't touch." That's aposematism, a warning sign written on the body. The lionfish does the same thing. Those bold stripes? They're a warning. The fancy fins? A warning. The spines? Definitely a warning. Every single thing about its appearance is screaming, "Don't try it." And the wild thing is, it actually backs it up. Those long, elegant spines aren't just for show. Each one is connected to a venom gland. When something bumps into a spine, pressure pushes it down into a sleeve, and venom shoots up through the spine like a tiny needle. The venom causes intense pain, swelling, sometimes paralysis in the area. For most predators, even one spine is enough to teach them a lesson they never forget. So the lionfish's strategy is simple. Be loud. Be obvious. Be impossible to ignore. And anybody who doesn't believe the warning pays the price. Once. After that, they remember forever. Now here's where the lionfish gets clever, and honestly kind of sinister. It doesn't just use its spines for defense. Watch how it hunts. A lionfish drifts toward a small fish. Slowly. Calmly. It's not in a hurry. Then, those big, beautiful pectoral fins start to spread. Wider. 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 The fins are now stretched out on either side like a giant umbrella, completely blocking the water around the prey. The little fish looks left. Wall of fin. Looks right. Wall of fin. Looks behind. Reef. Looks forward. Open mouth. The lionfish is herding it, like a shepherd guiding a sheep into a pen, except the pen is the lionfish's mouth. And once the prey is cornered, the lionfish opens its mouth so fast it creates a vacuum. The little fish gets sucked in before it even understands what just happened. Gone. Just like that. The whole hunt looks lazy, almost peaceful, but it's actually a perfectly choreographed trap. The fins aren't decoration, they're tools. Walls. Cattle prods, basically. The lionfish doesn't chase its food. It corners it. You know what I love about this animal? It hunts in the middle of the day. Most predators are cautious about hunting in broad daylight. Too much visibility. Too many eyes watching. Bigger predators might steal your prey. It's risky. The lionfish doesn't care. It hunts whenever it wants, wherever it wants. Because of those spines, basically nothing in its native habitat is willing to mess with it. Imagine being so untouchable in your neighborhood that you walk around openly in the middle of the day doing whatever you want. Nobody bothers you. Nobody challenges you. Nobody even comes close. That's the life of a lionfish in its home territory. It's a gangster in the truest sense of the word. But, and this is where the story gets really dark, something went very wrong. Sometime around the 1980s, lionfish started showing up in places they weren't supposed to be. The— the Gulf of Mexico, the Atlantic coast of the United States. places thousands of kilometers from their native home in the Pacific and Indian Oceans. How did they get there? Most likely, aquariums. People who kept lionfish as pets eventually got tired of them, or moved away, or didn't want to deal with cleaning the tank anymore. So they did the worst possible thing. They dumped them into the ocean. A handful of fish. That's all it took. Because here's what those people didn't understand. In the lionfish's native waters, it has natural enemies. Fish that have learned over millions of years to recognize its warning stripes. Predators that know which species can be eaten and which ones to avoid. But in the Caribbean, in Florida, in the Bahamas, nobody had ever seen one before. The fish there don't recognize the warning. The predators don't know what those stripes mean. The native species have no instinct telling them, stay away from the spiky one. So the lionfish walked into a paradise where literally nothing was afraid of it. And it took over. The numbers are honestly terrifying. In some areas of the Caribbean, lionfish have multiplied so fast that they now outnumber native predators by a huge margin. A single female lionfish can release up to 2 million eggs per year. Think about that. 2 million. And the eggs float. They drift with currents. They spread across hundreds of kilometers, settling on new reefs and starting new colonies wherever they land. It's not just an invasion. It's a takeover. In some Caribbean reefs, scientists have found that native fish populations have dropped by up to 90% in just a few years. Why? Because young native fish, the next generation, get eaten before they can grow up and reproduce. The lionfish isn't just removing fish from the reef, it's removing the future of the reef. And it gets worse. When you remove the small fish from a reef, you remove the herbivores, the grazers, the little fish that eat algae and keep the coral clean. Without them, algae starts to grow unchecked. It covers the coral, smothers it, suffocates it, and the reef itself begins to die. So the lionfish isn't just an invasive species. It's destroying the entire architecture of the ecosystem. Slowly, quietly, one small fish at a time. This is what happens when a top predator shows up somewhere it doesn't belong. But here's where the story gets interesting. Humans noticed. In the last 10 or 15 years, divers and biologists started fighting back. Lionfish hunting tournaments became a thing. Whole communities now organize spearfishing events, specifically to remove lionfish from the reef. Restaurants started serving them. Turns out, lionfish are actually delicious. White, flaky meat, mild flavor. People couldn't believe such a beautiful villain tasted so good. There's even a movement now. Eat the invasive species. Slowly in some areas, lionfish numbers are starting to drop. Not enough. Not fast enough. But it's something. And here's the most fascinating part. Some native predators are finally starting to figure things out. Sharks, eels, larger groupers. They've started experimenting. Some are learning to attack the lionfish from the side or below, avoiding the spines. Evolution is responding. Slowly. But it's happening. The reef is fighting back. There's a lesson in all of this that goes way beyond the lionfish itself. For millions of years, ecosystems develop balance. Every animal has its place. Every predator has its prey. Every prey has its escape strategies. Everything fits together like an incredibly complex puzzle that took countless generations to assemble. When you take one piece and drop it somewhere it doesn't belong, even something as small as a few fish from an aquarium, the entire puzzle can start to fall apart. The lionfish didn't choose to invade. It didn't plan this. It's just doing what it evolved to do. But because of where it ended up, it became a disaster. Now imagine a young coral reef in the Bahamas, somewhere quiet and out of the way. The water is clear. Light filters down through the surface. Small fish dart between coral branches, doing what they've always done. And drifting through the middle of all of it, fins spread wide, stripes glowing, spines extended like a king's crown, is a lionfish. It's not running, not hiding, not afraid of anything. To the untrained eye, it looks majestic, beautiful, almost regal. But for the reef around it, it's a slow-moving disaster. Quiet, patient, hungry. The poisoned gangster. A creature so successful at survival that it became a threat to entire ecosystems just by being itself. And the question we have to ask is, was it the lionfish's fault or ours? In a marine biology lab somewhere in the world, a scientist sets up a simple experiment. A glass jar, a locking lid, a piece of crab inside as bait. The whole thing gets lowered into a tank, and in that tank is one octopus. The scientist wants to know, can it figure this out? 20 minutes later, the lid is off. The crab is gone, and the octopus is back in its corner, pretending nothing happened. So the scientist tries again, this time with a child-proof lid, the kind humans struggle with. Same result. This time with a screw-top jar. Same result. A jar inside another jar. Same result. At some point, the scientist gives up, because they realize something genuinely uncomfortable. There is no jar an octopus cannot open. There is no enclosure it cannot escape from. There is no system designed by humans that this animal cannot defeat. Welcome to the world of the most wanted fugitive in the entire ocean. If the ocean had a most wanted list, the octopus would be at the top. Not because it's dangerous. It's not really. It's actually one of the more peaceful predators we've talked about. It's at the top of the list because nobody can keep this animal contained. Aquariums have lost octopuses to ventilation pipes. Scientists have caught them sneaking into other tanks at night to eat the fish, then sneaking back into their own tank before morning. There are documented cases of octopuses opening doors, climbing out of containers, squeezing through gaps the size of a coin. If you put an octopus inside a building, eventually the building has an octopus problem. So how does it do this? Let me show you. And I promise, by the end of this chapter, you're going to think very differently about what intelligence even means. The first secret is its body. An octopus has no bones. Let me say that again because it's important. No bones at all. The only hard part of an octopus is a tiny beak, about the size of a parrot's beak, hidden in the center of its body. Everything else is soft tissue, muscle, skin, 8 long, flexible arms. This means an octopus can squeeze through any hole bigger than its beak. So a 5-kilogram octopus can fit through a hole the size of a coin. Think about that. A creature larger than your forearm, slipping through an opening you could barely fit a pencil through. No bones to break, no skeleton to compress, just pure liquid muscle reshaping itself. There's a famous video of a large Pacific octopus passing through a crack about 2 centimeters wide. It looks like physics is broken, like the laws of nature don't apply to this animal. And honestly, they kind of don't. But the body is just the beginning. Now we need to talk about the brain. Or rather, the brains. Yes, plural. An octopus has 9 of them. 1 central brain in its head like ours, plus 8 smaller brains, 1 in each arm. This is the part that always blows my mind. Each arm of an octopus can think for itself, independently, without instructions from the main brain. So when an octopus is solving a puzzle, it's not 1 mind working on it. It's 9 minds, all working at the same time, in different places, on different parts of the problem. Imagine if your hands could think. If your fingers could explore independently while you focused on something else. If each of your limbs could investigate a different problem at the same moment. That's the everyday reality of being an octopus. Now here's where things get really weird. Every single sucker on an octopus's arm, and there are hundreds of them, can taste and smell. Read that again. The octopus tastes the world by touching it. When it reaches into a crevice, it's not just feeling around, it's tasting every surface, every bit of rock, every shell, every piece of seaweed, building a complete sensory map of an environment it can't even see. So when it explores a jar with a screw-top lid, it's not just figuring out the lid mechanically, it's tasting the metal, sensing the threads, feeling the resistance, reading the entire problem through thousands of independent sensors at the same time. By the time it reaches the lid, it already understands the puzzle better than the human who designed it. Let me tell you about a real experiment that I find absolutely incredible. Scientists put octopuses through what's basically an IQ test for animals. Mazes, puzzles, mechanical problems, things you'd expect to challenge a smart dog, or maybe even a chimpanzee. The octopuses passed everyone. Then the scientists did something more interesting. They showed an octopus how to open a jar, let it watch through the glass while a human opened it. Then they gave the octopus its own closed jar, and the octopus copied the technique, almost exactly. This is observational learning, the same kind of learning we use, the same kind of learning crows use, dolphins use, primates use, and it's happening in an animal that evolved on a completely different branch of the tree of life, separated from us by over 600 million years. Octopuses are intelligent in a way that almost nothing else on Earth is, and we don't even fully understand it yet. Now let's talk about how it disappears. Like the cuttlefish, its close cousin, the octopus can change color and texture in less than a second. It can blend into rock, sand, coral, anything. The same chromatophores, the same papillae, the same magic trick. But the octopus does something even sneakier than the cuttlefish. It mimics other animals. There's a species called the mimic octopus that can imitate the shape and movement of more than 15 different sea creatures. It can flatten itself to look like a poisonous flatfish, spread its arms to look like a venomous lionfish, stick 6 arms into a hole and wave the other 2 to mimic a sea snake. This isn't camouflage. This is acting. The mimic octopus chooses which animal to imitate based on which predator is approaching. If it sees a damselfish, which is afraid of sea snakes, it does the snake impression. If it sees a different threat, it switches characters. It's literally selecting the right disguise for the right audience. I don't even know how to describe how impressive that is. There's nothing else in the animal kingdom that does this. When an octopus does get caught or threatened or cornered, it has one final trick: the ink. But here's the part most people don't know. The octopus's ink isn't just a smokescreen. The ink is shaped like the octopus itself. When it shoots out its ink cloud, the cloud forms a body-sized blob in the water, roughly the same size and shape as the octopus that just released it. The predator strikes at the decoy. The real octopus is already gone, and it gets sneakier than that. The ink contains chemicals that interfere with the predator's sense of smell, basically jamming the predator's biological tracking system. So even if the predator realizes the decoy isn't real, it can't follow the scent trail. The octopus has, in a single gesture, deployed both a visual decoy and a chemical jamming device at the same time. It's not just escape. It's a coordinated, multi-layered counterintelligence operation. But here's where the story gets sad. For all of this brilliance, for all of this intelligence and creativity and adaptability, the octopus only lives a few years. Most species live just 1 to 2 years. Even the largest, the giant Pacific octopus, lives only about 4. That's it. A creature that can solve puzzles, learn from observation, manipulate objects with 8 independent limbs, change shape, change color, recognize individual humans, gets only a handful of years on this planet. And the way it dies is even more heartbreaking. After a female octopus lays her eggs, she stops eating. Completely. She spends every minute of every day cleaning her eggs, protecting them, fanning fresh water across them. She doesn't hunt. She doesn't rest. She just guards the eggs with everything she has. By the time the eggs hatch, which can take months, she's exhausted, starved, and dying. She watches her babies drift off into the ocean, and then she dies. Every single female octopus dies this way. It's not a tragedy. It's just how their biology works. They put everything they have into one final act of motherhood, and then they're gone. There's something really profound about all of this when you think about it. The octopus is one of the most intelligent animals in the ocean, possibly on Earth. It can learn, problem solve, manipulate tools, recognize faces, and outsmart almost anything that tries to contain it. And yet, it lives a brief, almost fleeting life. It barely gets time to use any of that intelligence before it's gone. It makes you wonder what an octopus thinks about, what it feels, what it knows. We may never fully understand. Their minds are too different from ours. They evolved on a path so distant from mammals and birds that comparing them to us is almost meaningless. But here's what we do know. When an octopus looks at you, and they really do look at you, with intent, with curiosity, with what genuinely seems like awareness, there's something on the other side of those eyes. Something thinking, something watching, something deciding what to do next. Right now, somewhere on a reef, an octopus is hidden inside a crack in the rocks. You could swim past it 10 times and never notice. Its skin matches the stone perfectly. Its body is tucked into a space smaller than a coffee mug. It's watching the world, reading it, tasting the currents, listening to the vibrations of nearby creatures. If you tried to catch it, it would already know. By the time your hand moved, the octopus would be a cloud of ink and a streak of color disappearing into a crevice you didn't even see. You wouldn't catch it. Nobody catches it. The escape artist always escapes. Look at this fish. Just look at it. Round body, silly little fins, big innocent eyes. Moves through the water like it has somewhere important to be, but isn't really sure where. It's honestly kind of adorable, like a balloon that learned to swim. You'd never guess, looking at this slow, awkward, almost cartoonish creature, that you are looking at one of the most dangerous animals in the entire ocean, because inside that goofy little body is enough poison to kill 30 grown humans. This is the pufferfish, the poison dealer of the reef. Now, before we get into the science of it, I need you to really understand something. The pufferfish doesn't look like a killer. It's slow. It's awkward. It can barely swim in a straight line. If you put it next to a shark or a barracuda, it would look like a clumsy clown joining a fight club. And yet, sharks avoid it. Big predatory fish refuse to bite it. Even other reef hunters that will eat almost anything will swim right past a pufferfish without even glancing at it. Why? Because every single one of them learned the same lesson at some point in their lives. Eating a pufferfish is the last meal you ever eat. Let me explain what makes this fish so deadly. Inside its body, in its skin, its liver, its eggs, even its eyes, the pufferfish carries a substance called tetrodotoxin. Now I'm going to tell you something about tetrodotoxin that might genuinely scare you. It is one of the most powerful natural poisons on Earth. It's about 1,200 times more deadly than cyanide. A single pufferfish eaten whole contains enough tetrodotoxin to kill multiple adult humans. There is no antidote. There is no cure. If you eat enough of it, your nervous system simply stops working. Your muscles stop responding. Your lungs stop breathing. And there is nothing any doctor on Earth can do about it. This is what's hiding inside that cute, round, balloon-shaped fish, drifting peacefully through the coral. Nature has a sense of humor sometimes, and a dark one. But here's the part that I find absolutely fascinating. The pufferfish doesn't actually make the poison itself. Read that again. The most poisonous fish in the ocean doesn't produce its own poison. So, where does it come from? From bacteria. Tiny microscopic bacteria that live inside the pufferfish's body. These bacteria produce tetrodotoxin as part of their natural biology, and the pufferfish basically lets them live inside its tissues, slowly building up a stockpile of poison over time. It's a partnership, a friendship almost. The bacteria get a comfortable home inside a fish. The fish gets a built-in chemical weapon. Both species benefit. So the pufferfish is essentially a walking storage facility for someone else's poison. It's literally a dealer, holding inventory, carrying the goods. The street name fits perfectly. Now let me tell you about the pufferfish's most famous trick. You've definitely seen this before. Maybe in a documentary, maybe in a cartoon. The pufferfish puffs up. But have you ever actually thought about how it does that? Because it's wild. When threatened, the pufferfish gulps water, really fast, into a special expandable stomach. Its body is built like a balloon. The skin can stretch dramatically. The internal organs shift around to make room. And in just a few seconds, the puffer transforms from a normal fish-shaped fish into a giant prickly sphere. It can swell up to 3 times its normal size. Imagine if a human did that. Imagine if your body could suddenly inflate into a beach ball in 3 seconds. That's what's happening here. And as the body expands, hundreds of small spines that normally lie flat against the skin pop outward. Suddenly the puffer isn't just round and big, it's covered in needles. So now imagine you're a shark. You see a tasty little fish. You go for the bite. And mid-bite, the fish suddenly becomes an inflated, spike-covered, basketball-sized monster filling your entire mouth. You can't swallow it. You can't crush it. You can't even spit it out properly because of the spines. And, by the way, even if you somehow do swallow it, you're now poisoned. It's the worst possible meal a predator can choose. Here's something I find really beautiful about this. Every single shark, every barracuda, every grouper that swims past a pufferfish without attacking, learned that lesson somehow, either through their own near-death experience or by watching another fish die, or through generations of instinct passed down through evolution. The pufferfish's survival is built on the painful memories of every predator that ever tried to eat one. The reef remembers, and the lesson is permanent. But, and this is the part that always surprises people, the pufferfish doesn't like puffing up. It's actually a last resort. Inflating uses a huge amount of energy. It puts stress on the puffer's organs. It makes the fish slow and clumsy and easy to spot. If it inflates too often, it can hurt itself. So the pufferfish only does it when there's no other option. Most of the time, just being a pufferfish is enough. Predators see the shape. They see the slow, casual swimming style. They recognize the species, and they just keep going, looking for an easier meal. The pufferfish has reached a level of dangerous reputation where it doesn't even need to perform anymore. The threat alone is enough. That's the dream of every gangster, isn't it? To be so feared that nobody even tries. Now here's something nobody expects. The pufferfish is also kind of an artist. I'm not joking. In Japan, scientists discovered something incredible. Male white-spotted pufferfish create giant, intricate geometric patterns on the sandy seabed during mating season. We're talking about beautiful circular designs, sometimes 2 meters wide, made of perfectly arranged ridges and valleys, like crop circles, but underwater, and made by a fish. The male spends about a week creating one of these designs, swimming back and forth, carefully shaping the sand with his fins, adjusting tiny details, picking up shells and pieces of coral to decorate certain spots. When the design is finished, it's astonishingly precise, symmetrical, beautiful, almost mathematical. He does all of this to attract a female. If she likes the pattern, she'll lay her eggs in the center of it. So this same animal that carries enough poison to kill a horse is also one of the most artistic creatures in the entire ocean. How do you even reconcile those two things in one species? Nature is honestly so much weirder than fiction. Now I have to tell you about something the pufferfish has caused in the human world. In Japan, there's a famous dish called fugu. It's prepared from pufferfish. And here's the catch. If it's prepared incorrectly, it can kill you. Chefs in Japan need a special license to prepare fugu. They train for years. They have to pass specific exams. They have to know exactly which organs to remove, in what order, with what tools, and how to clean the meat to remove every trace of tetrodotoxin. A single mistake, a tiny piece of liver missed, a drop of contaminated knife touching the fillet, and the customer dies. People still do die from this every year. It's been happening for centuries. And yet, people keep eating it. Why? Because for some reason, humans are drawn to the danger. Eating a meal that could kill you has become a kind of ritual, a test of trust, a taste of mortality. The pufferfish has somehow created a cultural tradition built around its own poison. Even in death, this little fish controls the room. Now here's the most interesting twist in this whole story. Some predators are starting to figure things out. In certain parts of the ocean, scientists have observed sharks and other large fish learning to flip pufferfish upside down, eating only the parts of the body with less toxin. Some fish have even been seen targeting only the muscle tissue, avoiding the most poisonous organs. The animals are evolving. Strategies are emerging. This is the never-ending arms race of nature. The pufferfish develops a defense. The predators develop a workaround. The pufferfish responds with stronger defenses. And on it goes. 1 million years ago, there was an early ancestor of the pufferfish. Slow, awkward, and completely vulnerable. Through countless generations of predators eating its ancestors, those that survived passed on slightly stronger toxins, slightly faster inflation, slightly tougher skin. What we see today is the result of that long, brutal selection. A creature that has been forced, by death itself, to become more dangerous, more clever, more impossible to eat. The pufferfish is what happens when an animal has no choice but to weaponize itself. There's a quiet beauty to the pufferfish when you really watch one. It drifts through the reef without urgency. It doesn't dart away from divers. It doesn't panic when shadows pass overhead. It's calm in a way most reef fish never are, because it knows something the others don't. It knows that whatever wants to eat it won't. It knows that its body carries a story written in chemistry, a story that every predator in the ocean has eventually learned the hard way. It knows that fear comes for everyone except the ones who carry their own consequences. Right now, somewhere on a reef, a pufferfish is hovering near a coral branch, slow, round, almost smiling, watching the world drift by. And nothing, not the shark cruising in the distance, not the barracuda hunting nearby, not the grouper hidden in the rocks, wants anything to do with this little creature, because they all know the pufferfish doesn't need speed, it doesn't need teeth, it doesn't need to hide. It carries the price of attacking it inside its own body. And in the cold logic of the ocean, that makes it untouchable. The poison dealer. A reminder that sometimes the most peaceful-looking creatures are the ones you should respect the most. There's a hole in the reef, just a small dark crack between two pieces of coral. Looks empty, looks safe, looks like the perfect place to hide if you're a small fish being chased by something bigger. And that's the problem, because that hole isn't empty. There are eyes in there, watching, calculating, waiting. There's a body coiled inside that hole, long, muscular, patient, that has been waiting for hours for exactly this moment. And the second that small fish swims inside, the hole comes alive. A head explodes outward. Teeth flash. Jaws snap shut. The fish doesn't even have time to turn around. It's gone. The hole goes still again. Quiet. Innocent looking. Like nothing ever happened. But the body is still in there. Still waiting for the next one. This is the Moray eel, the reef's Alleyway mugger. And before we go any further, I have to tell you something. The Moray is not like the other predators we've met in this documentary. It doesn't hunt in open water like the Barracuda. It doesn't herd prey like the Lionfish. It doesn't outsmart you like the Octopus. The Moray works on a much simpler principle. It owns territory. A crack in the reef, a hole in the rocks, a tunnel between coral. Once a Moray claims that spot, that piece of real estate is its, permanently. And anything that wanders too close pays the toll. This isn't hunting. This is extortion. Let me describe what a Moray actually looks like, because most people have never seen one up close. Imagine a snake. Now imagine that snake is a fish. Now imagine that fish has the body of a python and the head of a nightmare. That's basically a Moray. They can grow up to 3 meters long. Some species reach the size of a fully grown man, Their bodies are thick, muscular, almost prehistoric. They have no scales, just smooth, slimy skin covered in a thick layer of mucus. That mucus is important. It lets them slide through razor-sharp coral without getting cut. It protects them from infection, and it makes them almost impossible to grab. You couldn't hold a moray if you tried. They'd slip out of your hands like wet rope, and then they'd bite you. Speaking of biting, let me tell you about the moray's mouth, because this is where things get genuinely terrifying. The moray has 2 sets of jaws. I'll wait while that sinks in. 2 sets of jaws. The first set is what you see. Long mouth, sharp curved teeth, jaws that snap shut like a steel trap. But hidden inside the moray's throat is a second set of jaws, smaller, sharper, and they can shoot forward into the mouth like a separate creature reaching out from inside. This is real. This is not science fiction. When a moray catches prey with its first set of jaws, the second set lunges forward, grabs the prey from inside the mouth and drags it backward down the throat. Imagine if you bit into your food and a second mouth shot out from your throat to pull it down. That's what's happening every time a moray eats. There is no other animal on Earth, no other animals, that has anything like this. The moray is so specialized for hunting in tight spaces that evolution gave it an internal grappling hook just to drag victims down its narrow throat. It is, hands down, one of the strangest pieces of anatomy in the entire animal kingdom. Now, let me clear up something important. You've probably seen photos or videos of moray eels with their mouths wide open, teeth exposed, looking like they're about to attack. Maybe you thought they were aggressive, or angry, or threatening. They're not. That open mouth thing, that's just how they breathe. Most fish breathe by passing water through their gills as they swim. They never stop moving, so they never stop oxygenating their blood. The moray doesn't swim much. It spends most of its life jammed inside a tight hole in the rocks. It can't pump water through its gills the normal way, so it has to do it manually. Every couple of seconds it opens its mouth and gulps. Closing the mouth pushes water across the gills. Opening it again pulls in fresh water. That terrifying gaping mouth full of teeth, that's just a moray breathing. It's like seeing someone yawn and assuming they're about to attack you. Okay, so the moray sits in a hole, waits for prey, snaps with terrifying jaws, drags victims down its throat with a second mouth. Pretty straightforward, right? Wrong. Because here's where the moray does something that when scientists first observed it, they couldn't believe was real. The moray hunts in partnership with another species, specifically with groupers. Groupers are big, slow, powerful fish that live on the same reefs. They're great at catching fish in open water, but terrible at chasing prey that hides in cracks. The moray is the opposite, master of the cracks, useless in open water. Together, they're unstoppable. Here's how it works. A grouper that wants to hunt with a moray will swim up to the moray's hole and do something that looks bizarre. It shakes its head rapidly, side to side, almost like a vibrating dance. This is a signal. The grouper is asking for help. The moray sees the head shake and emerges from its hole. It follows the grouper across the reef. When the grouper finds a fish hiding in a crack, a fish too deep for the grouper to reach, it stops, hovers near the spot, and points its body at the entrance. The moray gets the message. It slithers into the crack. The hidden fish panics and bolts out the other side, right into the grouper's open mouth. Whichever predator catches the prey gets to keep it. There's no fighting over it. No competition. The partnership respects the rule. Whoever catches it, eats it. I want you to really understand how incredible this is. 2 completely different species, a fish and an eel, communicating with each other, coordinating attacks, using specific signals, sharing the spoils based on outcome. This is teamwork. This is cooperation between different species, and it's based on intelligence, communication, and mutual benefit. For decades, scientists believed this kind of behavior only happened among mammals, like dolphins or wolves working together. The discovery that fish and eels do the same thing rewrote what we thought we knew about animal intelligence. The Moray isn't just a brutal mugger, it's also a strategist, a criminal with connections. Now let's talk about something nobody expects. Despite being one of the most fearsome-looking creatures on the reef, the Moray has friends. Specifically, small, cleaner fish, tiny shrimps, little wrasses. These small creatures swim into the Moray's mouth, walk around between its teeth, pick parasites off its skin, clean dead tissue from its gills, and the Moray just lets them. Doesn't bite, doesn't snap, doesn't even flinch. It opens its mouth wide and lets these tiny creatures crawl all over the inside of its jaws, completely defenseless if the Moray decided to attack. But it never does. The Moray needs them. Without cleaner fish, it would be covered in parasites. So both species follow an unspoken truce. Inside this mouth, nobody gets hurt. It's a strange thing to witness. This terrifying-looking creature, with its needle teeth and powerful jaws, gently parting its lips while a fish the size of your fingernail walks across its tongue. In the underworld of the reef, even the toughest mugger has rules. Now let me tell you something most people don't know about the Moray's life story. These animals don't start out as nightmare creatures. When a Moray eel is born, it's almost invisible. Baby Morays go through a stage called the leptocephalus stage. They look nothing like adults. They're transparent, flat, ribbon-shaped, so clear you could see through them. These tiny see-through ribbons drift through the open ocean for months, sometimes years, floating with the currents, eating microscopic organic matter, slowly developing. Then eventually they settle onto a reef. Their bodies thicken, their pigment darkens, their teeth grow in. The transparent ribbon transforms into the muscular predator we know. It's almost like a butterfly metamorphosis, except instead of becoming beautiful, it becomes terrifying. Every nightmare creature started as something fragile. Here's a question I find myself thinking about a lot. If the Moray is so powerful in its hole, why doesn't it leave? Why doesn't it hunt more openly, take more territory, expand its empire? The answer is brutal. In open water, the Moray is not at the top of the food chain. Larger sharks will eat Morays. Big groupers will eat them. Yes, the same species they sometimes hunt with. Other large predators see a Moray out in the open as an easy meal. A long, slow-moving piece of muscle with no scales. The Moray's whole power is contextual. Inside its alley, it's the king. Outside the alley, it's prey. So it stays, year after year, sometimes for its entire life, watching the same patch of reef, defending the same crack, waiting for the same kinds of fish to make the same kinds of mistakes. Some Morays live for decades in the exact same hole, a lifetime spent inside a few square meters of stone. Power is sometimes very, very small in scale. There's something almost philosophical about the Moray when you think about it. It's not a glamorous predator. It doesn't have the speed of a Barracuda or the intelligence of an octopus or the spectacle of a lionfish. What it has is patience. The willingness to wait in darkness for hours, for days, for weeks if necessary. To occupy one tiny spot of the reef and defend it absolutely. To turn one crack in the rocks into an entire kingdom. The Moray reminds us that not all power is loud. Not all dominance is visible. Some predators rule by simply being there, by occupying the right space at the right time with the right kind of unwavering presence. In the city of the reef, while everyone else is moving and fighting and chasing, the Moray just holds its ground. And its ground eventually holds everyone. Right now, somewhere on a reef, there's a hole in the coral. Looks like nothing. Looks empty. You could swim past it. You could swim over it. You'd never know. But inside that hole, coiled in darkness, eyes steady, mouth pulsing rhythmically with each breath, is the Alleyway mugger. watching the boulevards of the Reef, waiting for someone desperate enough to try and use its tunnel as a shortcut. Anyone who does will discover the same hard lesson the Reef has been teaching for millions of years. Every alleyway has a landlord, and in this one, the landlord has teeth. A seal sits on a sheet of ice, alone in the middle of the Antarctic Ocean. It's safe up here. It knows that. Predators can't reach the surface of the ice. Down in the water there are dangers, but up here on this drifting white platform, the seal is untouchable. Or so it thinks. Then it sees them. 3 black fins, cutting through the water in a perfect line. Not rushing, not panicking, moving with the calm precision of a military formation. The seal freezes. It knows what those fins are. Every animal in the ocean knows what those fins are. But it doesn't matter that it knows, because what's about to happen has been rehearsed, practiced, passed down through generations, refined over centuries. This isn't a chase. This isn't a hunt. This is an operation. And the seal is the target. Welcome to the world of the orca, the most intelligent predator in the ocean, possibly on Earth. If the Reef is a city, full of small-time criminals, alleyway thugs, drive-by killers and poison dealers, then the orca is something far above all of that. The orca is the crime boss, the one who runs the entire operation, the one with the family, the strategy, the network, the one who doesn't just hunt, who plans. And by the end of this chapter, I hope you'll see what makes the orca different from every other animal we've ever talked about in this documentary. Because the orca isn't just a predator, it's something closer to a civilization. Let me take you back to that seal on the ice. The 3 orcas circling in the water aren't just watching. They're communicating. They're talking to each other in clicks and whistles, a language so complex that scientists are still trying to decode it. One orca breaks off from the group. It dives deep beneath the ice floe. The other 2 line up perfectly side by side. They begin to swim, not toward the seal, but parallel to the flow, picking up speed, synchronizing their movements with the precision of Olympic swimmers. What they're about to do is one of the most extraordinary hunting techniques ever observed in the animal kingdom. They are about to generate a wave. By swimming together at exactly the right speed, in exactly the right formation, 2 adult orcas can push a wall of water in front of them. A wave. A real, controlled, weaponized wave. The wave hits the ice floe. The floe tilts. The seal slides toward the edge. And on the other side of that edge, already in position, already waiting, is the 3rd orca. Mouth open. Game over. Now I want you to really think about what you just witnessed. 3 different animals. 3 different roles. 1 scout sent ahead to position itself for the kill. 2 animals working in coordinated synchronization to manipulate physics, actually creating ocean physics, to dislodge prey from a position they couldn't otherwise reach. This is not instinct. This cannot be instinct. This is strategy. Real strategy. The kind that requires planning, role assignment, communication, and trust. There is no other animal on Earth that hunts like this. Not lions, not wolves, not chimpanzees. Nothing. The orca isn't following programmed behavior. The orca is thinking through the problem in real time, adjusting, coordinating, executing. And the most incredible part, this technique only exists in one specific population of orcas. Other orcas, in other parts of the world, don't know how to do this. Just like humans, orcas have culture. Different families have different techniques, different traditions, different recipes for how to hunt. The wave-hunting orcas teach this to their children. Their children teach it to their grandchildren. The knowledge passes down through generations, like a family business. It's not just biology anymore. It's tradition. Let me tell you something that completely changes how you should think about orcas. There isn't really one species of orca. I mean, biologically, yes. They're all the same species. But behaviorally, they're more like different cultures, different tribes, Some pods specialize in hunting fish. They almost never eat mammals. They have specific calls, specific routes, specific traditions tied to fish hunting. Other pods specialize in hunting seals. They use coordinated wave hunting like we just saw. They almost never touch fish. Some pods specialize in hunting sharks. I'll come back to that one in a minute because it's wild. And here's the thing. These different orca cultures don't really interbreed. They speak different dialects. They have different traditions. Even though they could mate, they choose not to. Like different ethnic groups within the same species. Scientists are now using a word they never used to apply to animals: cultures. Orcas have cultures. Plural. That's how human-like their society is. Now let me tell you about the shark hunters. There's a population of orcas off the coast of South Africa that has figured out how to hunt great white sharks. Yes, great whites. The most feared predator in the ocean. And the orcas don't just kill them. They've learned to flip them upside down. When you flip a shark upside down, it enters a state called tonic immobility. Basically, it freezes. Its body goes limp. It can't fight back. It's a neurological response, completely outside the shark's control. The orcas figured this out. They figured out that this enormous, terrifying killing machine has a hidden weakness, and they learned to exploit it. In some areas of South Africa, the orcas have hunted so many great whites that the sharks have actually fled the region entirely, permanently. Just abandoned their hunting grounds because of these orcas. Let that sink in. The most feared predator in the ocean runs away from orcas because the orcas are smarter. The shark is a soldier. The orca is a general. The orcas live in family groups called pods, and these aren't loose social groups. They're tight, lifelong, multi-generational families. Sons stay with their mothers their entire lives. Daughters stay with their mothers their entire lives. Grandmothers, mothers, sons, daughters, grandchildren, all swimming together, hunting together, communicating constantly. Some pods have stayed together for over 100 years. The grandmothers are the leaders. Read that again. The leaders of orca society are the grandmothers, the oldest females, the ones with the most experience, the ones who know the migration routes, the hunting techniques, the locations of food during scarcity. When a grandmother orca dies, the entire pod suffers, sometimes for years, because she carried the knowledge that kept everyone alive. This is wisdom, pure, biological, generational wisdom. The orca pod is led not by the strongest or fastest, but by the oldest and wisest, the one who has seen the most. If that doesn't sound familiar to you, think about your own grandmother. Think about every human family. Think about every village, every tribe, every culture humanity has ever built. We are not as different from orcas as we like to believe. There's something truly profound about the orca's intelligence. Their brains are not just big, they're massive, roughly 4 times the size of human brains. But size isn't the most interesting part. What's interesting is the structure. The part of the orca brain responsible for emotion, social processing, and self-awareness is more developed than ours. Read that again, slowly. In some ways, the orca brain may be capable of deeper emotional processing than the human brain. We don't fully understand what that means. We can't get inside an orca's mind. But every observation we make of them, their family bonds, their grief responses when a pod member dies, their use of complex communication, their cultural traditions, all suggests something rich and emotional happening behind those eyes. When an orca looks at you, something is looking back, something deeply aware, something that is alive in a way we don't yet have the words to describe. There's a story I want to share with you that I think captures the soul of the orca. A few years ago in the Pacific Northwest, a female orca named Tahlequah lost her newborn calf. The baby died shortly after birth. What happened next stunned the world. Tahlequah refused to let her baby's body sink. She carried it on her head, pushing it through the ocean for 17 days, across more than 1,000 miles, refusing to let go. Her pod stayed with her. The other females took turns helping carry the body. They swam beside her, slowed down for her, waited for her. For 17 days, scientists watched, heartbroken. The whole world watched, because what we were witnessing was something we have no scientific word for. Grief, mourning, a mother's love that refused to surrender, even to death. Eventually, Tahlequah let her baby go. The pod continued its journey. Life resumed. But anyone who watched those 17 days will never doubt again that orcas feel things just as deeply as we do. Maybe deeper. Here's the most uncomfortable truth about the orca, though. Despite all of this, the intelligence, the family bonds, the culture, the strategy, the dominance, orcas are in trouble. The very things that make them powerful also make them vulnerable. As the top predator of the ocean, orcas accumulate every chemical pollutant we dump into the water. Mercury, PCBs, microplastics, industrial waste. All of it concentrates as it moves up the food chain. By the time it reaches the orcas, the levels are catastrophic. Some orca populations are now so contaminated that their bodies are classified as toxic waste when they die. They literally cannot reproduce successfully because of the chemicals in their tissues. The crime boss of the ocean, the most intelligent and successful predator on Earth, is being slowly poisoned by us. Not killed by hunters, not eaten by rivals, just poisoned by what we've done to the ocean itself. The seal hunters of Antarctica are still creating waves. The shark hunters of South Africa are still flipping great whites. The fish hunters of the Pacific are still teaching their grandchildren to herd salmon. Each pod still carries its own ancient knowledge. Each grandmother still leads her family. Each calf is still born into a tradition older than human civilization itself. For now. But the ocean is changing. Faster than the orcas can adapt their cultures to. Faster than their grandmothers can teach. What we lose when we lose an orca pod isn't just a group of animals. It's an entire culture. An entire library of knowledge. An entire way of being in the world that took thousands of years to build. We don't get to recreate that. Once it's gone forever. Right now, somewhere in the ocean, a pod of orcas is moving through the deep blue. A grandmother leads them. Her children swim beside her. Her grandchildren tumble and play in her wake. They are talking to each other in clicks and whistles we can't translate, sharing stories we can't understand, teaching the young ones lessons that were taught to their great-great-grandmothers in waters their ancestors swam through thousands of years ago. They are not just predators. They are not just animals. They are the closest thing the ocean has to a civilization. The crime boss of the sea. A reminder that intelligence is not the property of one species. Family is not the invention of humans. Culture is not unique to us. And maybe, just maybe, the most powerful creatures on this planet aren't the ones that conquered the land. Maybe they're the ones who chose to stay in the water. Okay, so we're here, the end of the video. And I want to share something I've been thinking about while putting this whole documentary together. When we started, I told you the ocean has its own underworld, its own criminals, its own bosses. And that's true. But only on the surface. The deeper truth is something else. Every animal in this video, the stonefish hidden in the sand, the cuttlefish painting itself into the reef, the barracuda hanging motionless in the blue, the lionfish with its venomous fins, the octopus solving puzzles with its 8 separate brains, the pufferfish carrying poison in its skin, the moray waiting in the dark, the orca leading her family through ancient migrations. None of them are villains. None of them chose to be killers. They are exactly what millions of years of pressure, evolution, and environment shaped them to be. Each one is a perfect answer to a specific question the ocean asked. How do you survive when you're slow? The stonefish answered with venom and stillness. How do you survive when you're soft? The octopus answered with intelligence. How do you survive when you have no armor? The cuttlefish answered with illusion. Every single one of these creatures is a masterpiece, a solution, a success story written in flesh and bone over countless generations. And here's what really hits me, if I'm being honest. We are the only species on Earth that gets to look at all of this and understand it. We're the only ones who can study the orca's family structure, the only ones who can decode the cuttlefish's color language, the only ones who can map the Moray's hunting partnerships. We are, in a real way, the only audience this incredible biological theater has ever had. And right now, at the exact moment in history when we finally have the science, the technology, and the awareness to understand these animals, we are also the generation watching them disappear. Coral reefs are dying, pollution is poisoning the orcas, invasive lionfish are rewriting entire ecosystems. The cuttlefish's library of disguises is getting smaller as the reefs fade. We are the first humans who ever truly understood what's down there. We might also be the last. I don't want to end this video on something heavy. So let me say one more thing. The ocean is not lost, not yet. Every reef that survives, every species that hangs on, every pod of orcas that keeps teaching their young, they're proof that life is incredibly stubborn, incredibly adaptive, incredibly willing to keep going. Our job isn't to save the ocean. The ocean has been saving itself for billions of years. Our job is just to stop getting in the way. If you made it all the way to the end of this video, genuinely thank you. 1 hour is a lot of your time. I don't take that for granted. If you enjoyed it, hit the like button. It really does help these long videos reach more people. And if you want more deep dives into the animals that quietly rule the ocean, subscribe to Marine Planet. There's a lot more coming. I'm curious about one more thing before you go. Which animal in this video surprised you the most? Not the one you expected to like, the one that genuinely caught you off guard. Tell me in the comments. I read them. Take care of yourselves. And wherever you are, go look at the ocean today. Even if it's just on a screen, it's the most extraordinary place on Earth, and it's still here, for now.